this is the exercise of the multiple regression, and we will be using this particular Excel sheet to understand what exactly the multiple regression is all about. Before we start, you need data analysis pack in the Excel. So how you can include this data analysis pack? You can go to the tools in the main tabs, and from there you can go to the Excel add-in. From the Excel add-in, you will be finding two add-in. One is analysis tool pack, and the other is solver add-in. So you need to check this analysis tool pack. If it is not checked or it is unchecked, you can click on this and you can click OK. Once you will click on OK, you will able to find this tool. You will be able to find this tool into the data tab and in data analysis. So we'll be using this data analysis and this data analysis tools, and we'll be using this regression regression test here from this. Okay, so let me make you understand what exactly the problem is. So this is the data where we are having the rainfall in year 1990 to 2010, and from this we would like to create the model, and we would like to predict the data of rainfall for year 2011 and onwards. And so we need to create the model. Now, if you see here, the assumption is the rainfall is depending on to the temperature in summer, temperature in winter, and wind speed. So this is the assumption that these three factors, three variables, independent variables impacting on my rainfall, that is my dependent variable. So to start with, the H0, that is called null hypothesis. Null hypothesis, and null hypothesis would be there is no relationship between three independent variable and rainfall, that is the dependent variable. Okay, so this is the null hypothesis. We shall accept or reject this null hypothesis. So we will be starting with this assumption that there is no relationship or none of these independent variables are impacting on my rainfall. So to start with, I'm at the regression, and into the regression, I need to give the input range, right? So input range Y, that is my outcome. So I will be selecting this is the outcome rainfall, which is Y for me, and Y is depending on the three variables. So I will be selecting three variables: max, summer, winter, wind speed, and this temperature and wind speed I have selected. So these three different variables I have selected, and then I would like to test it as 95% confidence level, and I have selected labels also. So I will check this particular box so that Excel will understand that my labels are into the first row, and then I need my output here at somewhere. Look at this. I would like to have my output here. So now as soon as I click OK, and then rest of the things I will be right now I don't need, so I will not be including into this, and I will be selecting OK. And after just the some analysis, regression would give me the result. Now for this result, I need to understand couple of things. I need to check what is the R square. So R square, let me mark with the color. Okay, so let me mark with the yellow color. And then I would like to check the p-value of this three. And then this is like significant. This is like significant F, which is also working as the p-value. Okay. So now the first thing first is I need to check R square. So R square indicates how much data are being explained by this particular model. So it says 89% of the this model is explaining 89% of this data. That means, yes, there is some dependency of this data on rainfall. That means, like in looking at the data, I will not be able to tell anything. But this analysis, multiple regression analysis, and specifically R square, the value of R square, it is saying me that how much data is being explained by this model. So 89% of the data is explained by model. So if your 85% of the data is being explained by this model, then yes, there is some impact of the independent variable on your model, and you can use this model for prediction for the future. Another important part is the p-value. P-value is the probability value. When we are checking this at 95% confidence level, that means we are having 5% chances of making mistake. That means if our p-value is more than 0.05, that is 5%, then we will be considering that we will be there is whatever null hypothesis is correct. So at the p-value is below 0.05, will reject the null hypothesis. So there is a simple saying that p is low, null has to go. So if you see the significance of f is also less than, like if we consider this p, then it is also the value of it, this is below zero, very much below 0.005. That means this model is like, will be p is low, null has to go. So yes, definitely the null hypothesis, we failed to accept this null hypothesis. That means there is some relationship between the independent variables and rainfall, the dependent variable. Now, which are the independent variable is impacting here? So let us check independently or individually which particular independent variable is impacting on my output. So for that, let us check the individual p-value. So let us check the individual p-value, and if we see the p-value of maximum summer temperature, and that is 0.001, which is below 0.05. So yes, this is below 0.05. It is impacting on my rainfall. Look at this winter. The winter temperature is 0.59. That means it is way ahead or way above the probability value of 5%. That means it is not impacting on my dependent variable. So here it is clear that maximum winter temperature is not impacting on my outcome. And then third one is the wind speed. So wind speed is also 0.002, which is below 0.05. So it is it says it is impacting on my maximum summer. It is impacting on my dependent variable, that is the rainfall. Now there are three questions. What is the conclusion for this exercise? And the answer is these independent variables are impacting on my output. Then the second question is what does p-value indicates? So p-value from this model indicates that there is a relationship between the independent variable and dependent variable. However, the maximum winter temperature is not impacting on to the rainfall. And the third one is what is the prediction for year 2011. So if we would like to predict something for 2011, then we need to create the model here. So what is the model? The model would be y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c, right? So basically this m1 x1 m2 x2 m3 x3 plus c is the y is equal to mx plus c model. Now how to identify, like, this m1 is the coefficient of the independent variable. So m1 here would be m1 x1 would be the max temperature, that is the first independent variable, and we are getting the coefficient of it as 0.48. M2 x2 M2 would be minus 0.138. So it is like, the maximum winter temperature, and M3 would be 1.007, and X3 would be wind speed. And then C is the intercept, and intercept would be 20.6955, right? So if we would like to predict something about so here, let's say if I would like to predict about the 2011, and in year 2011, let's say I'm having the temperature of 45 and the winter temperature of 23, and I'm having the average wind speed of 4 kilometers, then what would be the y? So the y would be m1 x1. So m1, I'm having m1, okay, m1 into into, I will be clicking on X1 plus M2 is this one into my this winter temperature plus this is the wind speed into my average speed and plus the coefficient of or intercept, right? So I will be coefficients, intercepts coefficient would be C and it is I-20. And if I click here, I would be getting 43, that is the rainfall, 43 inches I'm expecting based on this model. And again, once I will change these figures, this will also be changing based on the model we have created. So this is how you can interpret it. And what is next? Now we have seen that this winter temperature is not impacting on the output. So we can discard it and we can run the model once again, and we can again can get the different model with M1 X1 and M2 X2, and that would be the reversed one because we have discarded the independent variable which is not impacting on rainfall. So this is how you can actually complete your exercise for the regression. It has been widely used for sales forecasting, your purchase, for your production forecasting, and most of the sellers who are selling the number of products based on the customer experience, they are using the multiple regression analysis for judging or for getting the idea about how which particular item they need to keep or which particular item they need to sell, and which particular parameter is impacting onto the customer satisfaction. So all those kind of analysis you can do with the multiple regression. So if you are liking this example, do not forget to subscribe the channel, and we will be coming up with more such examples in coming time. Thank you so much.